Right now, somewhere on your body, there is a small itch. You have not noticed it yet, but the moment you read this sentence, you will feel it. That is not a coincidence. That is your nervous system doing exactly what it evolved to do. You scratch it. Instantly, there is relief. A wave of something close to pleasure spreads under your skin. For a few seconds, everything feels better. Then, strangely, the itch comes back, sometimes worse than before. You scratch again and again. Your ancestors did this too, standing in the same spot, chasing the same fleeting relief. But the real reason you scratch is far stranger than simple comfort. It is a battle happening inside your own brain, one your body has been losing on purpose for millions of years. Before you go further, if your brain likes uncovering hidden reasons behind everyday things your body does, subscribe. Leave a comment with the strangest itch you have ever had. And if this video is already pulling at something curious in you, a like helps more people find it. Start with the itch itself. Scientists call it pruritus. It begins in your skin where thousands of nerve endings sit ready to detect anything crawling, biting, or irritating the surface. A mosquito lands, a plant brushes your arm, a stray fiber from your shirt shifts against your neck. Specialized nerve fibers fire a signal. That signal races up your spinal cord and into your brain. Your brain interprets it as one simple command: scratch here. Why would your body build an alarm system this specific? The answer starts with survival. For most of human history, the biggest threats to your skin were not fabric tags or dry winter air. They were parasites, ticks, lice, biting insects that could burrow in, feed, and spread disease. An itch was an early warning system, a way for your ancestors' bodies to say something has landed on you and it needs to come off right now. The itch was not a nuisance. It was protection. That's why scratching feels good in the first place. When you drag your fingernails across an itchy patch of skin, you're not just satisfying an urge, you're triggering a small, controlled amount of pain. And pain, it turns out, is one of the most effective tools your nervous system has for silencing an itch. Here's where it gets interesting. In 1965, researchers Ronald Melzack and Patrick Wall proposed something called gate control theory. Their idea was simple but powerful. Your spinal cord has a limited number of channels available to send sensory information up to your brain. Pain and itch often compete for the same channels. When you scratch hard enough to create a mild pain signal, that signal can override the itch signal traveling through the same neural gate. Your brain gets a rush of pain, and for a moment, the itch simply can't get through. The relief you feel is not your body eliminating the itch, it's your body distracting itself with a slightly stronger, more urgent signal. But that's only half of the story. Your brain is not a passive gatekeeper here. It's an active participant, and it rewards you for scratching. Researcher Zhou-Feng Chen at Washington University in St. Louis studied this reward system. His team found that when you scratch an itch, your brain releases serotonin, a chemical closely associated with mood, pleasure, and pain relief. That serotonin travels along pathways meant to suppress pain, except there's a catch. Some of that same serotonin leaks over into neurons that control itch sensitivity, and instead of calming them down, it makes them fire more intensely. In other words, the very chemical your brain releases to reward you for scratching also makes the itch worse afterward. That's why one scratch is never enough. That's why an itchy mosquito bite can turn into a raw, irritated patch of skin after a few minutes of relentless scratching. You're not failing to control yourself. You're caught inside a feedback loop your own brain chemistry built. Think about what that means. Every time you scratch, you get a small hit of pleasure from pain relief and serotonin release. And every time, your nervous system quietly raises the itch signal right back up, waiting for you to scratch again. It's a cycle almost perfectly designed to keep you coming back. Dermatologist and itch researcher Gil Yosefich, who has spent decades studying chronic itch conditions, has described the itch-scratch cycle as one of the most stubborn loops in the body, one that can persist long after the original irritant is gone. This helps explain something almost everyone has experienced: an itch that won't stop even after you've scratched it raw. In people with chronic skin conditions like eczema or psoriasis, this cycle can spiral out of control. The skin barrier weakens, nerve endings endings become hypersensitive. Scratching, which once brought quick relief, starts to make the itching more frequent and more intense over time. What began as a simple protective reflex becomes a self-sustaining loop that outlives its original purpose. Now, step back further into evolutionary time. Why would a system this imperfect survive natural selection for so long? Because in the environment your ancestors lived in, an occasional overreaction to a lingering itch was a small price to pay compared to leaving a biting parasite untouched. A body that scratched too much was mildly irritated. A body that didn't scratch enough could end up infected, weakened, or carrying disease. Evolution doesn't build perfect systems. It builds systems that are good enough to keep you alive long enough to reproduce. The itch-scratch cycle, messy as it is, cleared that bar for millions of years. Consider how sensitive this alarm really is. Your skin doesn't wait for something to actually bite you before it reacts. Sometimes the faintest brush of a loose hair on your arm is enough to trigger the same nerve pathway as an insect bite. Your nervous system would rather sound a false alarm than miss a real threat. This is the same logic that shows up everywhere else in biology. A smoke detector that goes off when you burn toast is annoying. A smoke detector that stays silent during an actual fire is fatal. Your itch response was built with the same bias towards overreacting rather than underreacting, because in the ancestral environment, underreacting was the far costlier mistake. There's also a social dimension to itching that most people never think about. Have you ever noticed that watching someone else scratch can make you want to scratch too? This is not imagination. Researchers studying what's called contagious itch have found that simply seeing another person scratch, or even reading a detailed description of an itch, can activate the same neural circuits involved in your own itch sensation. Some scientists believe this response may have had a protective function in early human groups. If one person in a tight-knit group started scratching at parasites, it may have benefited everyone nearby to become more alert to the possibility of lice, mites, or fleas spreading between them. An itch in this light was never entirely private. It was a signal that could ripple outward to the people around you. This also explains why itching tends to worsen at night. Your body's production of cortisol, a hormone that naturally suppresses inflammation and dulls certain nerve signals during the day, drops as evening approaches. With less of that natural dampening effect, nerve fibers in your skin become more responsive, and itch signals that were easy to ignore during a busy afternoon can suddenly feel impossible to ignore once you're lying still in bed. Combine that with less external distraction and a slightly warmer skin temperature under blankets, and nighttime becomes the perfect condition for the itch-scratch cycle to take over. There's another layer here too, one that goes beyond parasites and survival. Some researchers have pointed out that itch and pleasant touch share overlapping neural pathways. Neuroscientist Francis McGlone's work on the skin's specialized touch fibers found that certain types of gentle stroking activate reward centers in the brain almost independently of any itch at all. This is part of why a light scratch on your back from another person can feel deeply satisfying, even when there was no itch there to begin with. Your skin is wired to find a certain kind of friction inherently rewarding, a leftover of the same system that once made grooming and social touch essential for survival in group-living primates. Look at your closest living relatives for a moment. Chimpanzees and other primates spend hours each day grooming one another, picking through fur, removing debris, and yes, scratching at each other's skin. This is not just hygiene. Grooming builds trust. It lowers stress hormones. It reinforces social bonds within a troop. Some researchers studying primate behavior believe the pleasure humans feel from scratching and from being scratched by another person is a direct descendant of this ancient grooming instinct. Long before your ancestors had language, they had touch. And touch that removed something irritating from the skin was rewarded with a small dose of pleasure, encouraging the behavior to continue. You inherited that reward system, wired into skin that no longer needs a grooming partner to feel it. This is also why an itch you can't reach is uniquely maddening. A spot in the middle of your back, just out of fingertip range, can feel far more urgent than an itch you can immediately scratch. Part of this comes down to the same distraction and gate control mechanism working against you. Without the ability to deliver a competing pain signal, the itch signal travels uninterrupted, and your brain has no relief valve to release the pressure. It's a small, almost comic reminder that this entire system was built for hands, for social grooming, and for immediate action, not for isolated, unreachable irritation. Even stranger, some people experience what researchers call phantom itch, a sensation of itching in a limb that no longer exists after amputation, or on skin that shows no visible irritation at all. This happens because the itch sensation is not purely a property of your skin. It's ultimately constructed in your brain, using signals that can sometimes fire even without an external trigger. The itch you feel is real to you, but the alarm itself is generated somewhere between your spinal cord and your brain, not solely at the site where you feel it. This is part of why chronic itch conditions can be so difficult to treat. The problem isn't always in the skin. Sometimes it's in the wiring. So the next time you feel that small, maddening prickle on your arm, your neck, or your scalp, you're not experiencing a random malfunction. You're feeling the echo of an ancient alarm system, one built to protect your ancestors from parasites they couldn't see. And when you finally give in and scratch, you're not just relieving an irritation, you're triggering a spinal cord shortcut discovered in a 1965 laboratory, a serotonin reward loop mapped out in a modern neuroscience lab, and a touch-based pleasure circuit that predates written history. The relief feels simple. The mechanism behind it is anything but. Somewhere on your body, right now, there is still a small itch waiting, and now you know exactly why it is there, why scratching it feels so good, and why, a few seconds later, it will probably come right back.